So today I'm here to solve this search insert position problem. It's a LeetCode daily. And we have been given a sorted array of distinct integers and a target value. We have to return the index if the target is found. If not, return the index where it would be if it were inserted in order. You must write an algorithm with O log n runtime complexity. It said that we have to write O log n. So that means we will have to do binary search. Linear time ON won't be like possible since it's gonna be O of n. So let's try to do it. Binary search, that is O of log n. If we were to do it in O of n, it would be simple. We would like go from here one by one since it's uh, in a sorted array. So we would just simply keep going until we find a bigger number, and if we find a bigger number without finding our target, we would just simply return uh, this index minus one. So in this case, we will find five, and so we return the index two. And in this case, we don't find 2, instead we find a 3 that is bigger than 2. So we return this index as our insert index, that will be 1. Okay, let's start coding. For binary search, we know that we have to take 2 pointers, left and right, and mid, like start and end and mid. So let's just start with it. Let start equals to 0 initially. Let end equals to nums dot length. Then while start is less than equals to end, we calculate mid. Let mid equals to, let's check the constraints first. 10 raised to power 4. So it will be like start plus start plus end divided by 2. Let's make it, since it's JavaScript, let's make it float. Math dot float. We don't have to make it a floor, we just have to make this one. Okay, why is it showing an error? I missed an I. If now we check if we have found our number. If mid is equals to target, we return mid. We return the index if we have found the number. Otherwise, what we do is we see if mid is less than target. So in that case, that means our number will be inserted like after this number. So we will have to move our start. So suppose we have to find 5 here. So what we will do is we'll take mid will be 3. The mid, this is smaller, so we skip this, then start from here. So we make start as mid plus 1, and else we make equals to mid minus 1. And then if we can't find it, then we return start. Let's see if this works. So for this example, let's see. So we have start as 0, that is 1. We have end as 0, 1, 2, 3, 1, 2, 3, 3 as 6, and we have target as 5. Then our mid will be 0 plus 0 plus 3 and minus start. 3 minus 0 divided by 2, that will be 1.5. Since we take floor, it will be 1. So mid of 1, that is 3. 3. Since 3 is less than our target, we move start to mid plus 1. So mid was 1. So we make start equals to mid plus 1, that is 1 plus 1, which is 2. And then again with and equals to 3. Let's remove this 6. We only look at the indexes for now. And we calculate mid as 2 plus 3 minus 2, that is 1 divided by 2. This will be 2.5 since we are rounding down, so it will be 2. And then this is 2 is 5. 0, 1 to 2 is it's 5. Since then we come here and then we have found the target, we return mid. Return, that is correct. Let's look at the other example where we can't find 2. Okay. So here we have input nums 1356, target is 2. We start same, and then we have mid, that is 3. This is bigger than 2, so we go to else and then we make mid minus mid minus 1, and will be mid minus 1 equals to what is it, and was mid was 3, mid was 1, so we make it 0. And start was also 0, start is also 0, and is 0 as well. So in this case, start and end is matching at the same index. What we do is we calculate mid equals to 0 plus 0, mid is also 0. So this will return mid as 0, 0 minus 1. This is less than target. 1 is less than target. So what we do is we make start as mid plus 1. So start moves to 0 to 1. It should work. Let's see. It didn't work for some reason. Why? Expected is 2 and we return 5. We returned mid. Oh yeah, right. We had to compare if mid of nums. This should work now. Let's see. Yeah, it worked. Nice. So since it's a binary search, we have a time complexity of O of log n. It was not so straightforward, but yeah, if we were to do it using a linear search, it would be much simpler, and we could do it like just keep searching, keep looking one by one, and then once we find one larger number, we return it as the index. But since we had to do it in O of log n, we used binary search. It was pretty simple and pretty straightforward. Yeah. Thank you. That's all. Bye bye.